This is 2.4a. This is the chain rule. So this is part A of the chain rule. I call it off the chain because we are legit like that. So let's talk about a composite. So if you've ever played a sport like baseball or tennis or golf, what's a composite? What does a composite mean?
It's made of wood and, well, for baseball, it's like made of two different things.
It's made of two different things. Two different things combined into one. All right, and that's what a composite function is as well, is that it will have multiple functions and it makes up one function. So I want you to write this thing out. I want you to write f of g of x. This is a composite function. However, when I take the derivative of a composite function, I have to take the derivative of my outside function first. And so that's why it's f prime of g of x. And then by the chain rule, I have g prime popping out. And so this is how we take a derivative of any composite function. Kind of like gears. If you turn one gear, what happens to the next one? Turns the other one. This one would build torque because it goes from a smaller tooth gear to a larger tooth gear. All right. But that is a composite function. All right. So when you have one thing inside of another. All right. So sometimes we call this innermost composite U. All right, it's like a U substitution. And so then you'd have like FU. And so then when we take the derivative of the outside, it'd be F prime U. But then we'd take the derivative of the inside, which a U prime pops out. All right, so on this one, I want to figure out what's the innermost composite and the outermost composite on these functions. So this one I have 1 over x plus 1. So what would be my innermost composite of this function? X plus 1. X plus 1 is my innermost composite. And so then my outer composite is like 1 over u. All right? So then, let's do it again. So if I have sine of 2x, what is my inside part?
Cosine.
2x. 2x is my inside part. And so then what's my outside part?
Cosine.
I don't even see a cosine. It's what?
I know, I thought you were taking
It's sine x. We're not taking a derivative at all. Okay, we're just talking about inside and outside composite parts. All right, so this one, I have this square root of this 3x squared minus x plus 1. What is my inside composite?
3x.
3x squared minus x plus 1, exactly. And so then what's my outside composite? The square root of x. All right, then let's do this one. Everybody most of the time messes this one up. What is my innermost composite of tangent squared x? What is my innermost composite? Tangent x, exactly. So then what's my outer composite? Squared, exactly. All right, because a lot of the times we should probably rewrite this one as like tangent of x quantity squared. That's how we should actually think of these. All right, but this is where we have some issues sometimes. All right, let's use the chain rule now. So I have y equals the quantity x squared plus 1 cubed. Before I knew this chain rule, what did we actually have to do? We had to expand this. We had to use our binomial theorem. And then some people were like, I don't remember the binomial theorem. And then it just got a little bit, we messed it up, didn't we? All right. And so now we don't actually need that anymore. Could you still do it that way? You could. However, it might take a little while. All right. So here we go. So dy dx is equal to what? What's my innermost composite here?
X squared plus 1.
X squared plus 1. What is my outermost?
Cubed.
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 And so guess what? I need to deal with my outer composite first. So what goes out front now?
3.
A 3. And then I still have x squared plus 1. And then that's now to a power of what? 2. And then I have to take the derivative of my innermost composite. And so what's the derivative of my innermost composite? 2x pops out. All right, and that's our chain rule. So there's our raw derivative. I'm just going to kind of simplify it up a little bit. So now you have 3 and 2x, and so what does that combine to? 6x times x squared plus 1 squirt. And so there is our derivative.
I'm sorry.
Next one, I'm going to call f of x is equal to this quantity of 3x minus 2x squared, and I'm raising it to the power of 8. So before this chain rule happened, I'd have 9 terms after I do my binomial expansion. And I don't feel like doing that. All right, that'd be a lot. All right, but that would be the only method to use until we know this chain rule. All right, so how do I notate taking a derivative? F prime. So what is my innermost composite? 3x minus 2x squared. What is my outermost composite?
8.
u to the 8th, right? All right, so now I have to go from outside, inside. All right, so what comes out front? An 8. So now I have an 8 times 3x minus 2x squared, and now raised to the what? The 7th power. Beautiful. All right, but then what pops out because the chain rule happened? What pops out?
The derivative of the inside.
The derivative of the inside. So what is the derivative of the inside? 3 minus 4x. All right. All right, so on this one, we're kind of done. However, they usually go in ascending powers. So now I'd have an 8 times 3 minus 4x, and then times 3x minus 2x squared to the power of 7. And so that would be our f prime. Now, was that a little bit quicker than doing a binomial expansion with 9 terms? A little bit. However, that's what it would actually equate to. All right, let's do another one. All right, here we go.
Find all points on the graph of f of x equals this cube root of x squared minus 1 quantity squared for which f prime equals 0 and those for which f prime of x does not exist.
All right, beautiful. So we have f of x is equal to the cube root of x squared minus 1 squared. However, when we take a derivative of this, I personally don't want to yet. What would I do?
Rewrite it.
I would rewrite it, exactly. And so what is this the same as?
Quantity
X squared minus 1 to the power of what? 2/3. Now we're going to take a derivative. And so now when I take a derivative, how do I notate taking a derivative? F prime of x. That tells our reader that we're taking a derivative now. And so what comes out front? A 2/3. And then I have x squared minus 1 to the what?
1 or negative 1.
The negative 1/3. But a chain rule happens here. So what pops out?
2x.
A 2x pops out. All right. And now let's use my childhood. Who gets to stay up top?
2/3 times 2x.
A 2 and a 2x. So what's left up top?
2 and 2x. Or 4x.
4x. Over, now who's on the bottom?
3 times.
A 3 times x squared minus 1 to the power of 1/3. All right.
Or you could just write
So now we're going to try to figure out when f prime is equal to 0. Essentially, what are we doing when we're finding f prime equals 0?
horizontal.
A horizontal tangent line. Exactly. All right. So when we set our derivative equal to 0, that is finding where we have horizontal tangent lines. So if I set this derivative equal to 0, what x value will equal 0? X equals what?
Wait, what does that mean?
What do you mean?
Oh.
0. Exactly. So I get x is equal to 0. Okay, because I'm really setting like 4x equal to 0. I'd get x equals 0. However, it says find all what? Points. Well, how do I find a point? I need an x and a y. So how do I get my y?
Oh, putting that in.
I substitute that into my what? My original. All right. And so we need to show that we're doing that. Kind of like equations of a tangent line. They just show up out of nowhere. All right. And so now when we substitute in 0, so I'd have 0 squared, which is 0 minus 1, which is negative 1. I square it, I get 1. I cube root it, I get 1. And so my point of horizontal tangency is 0, comma 1. All right. All right. This next part says, when does f prime not exist? So when does a derivative not exist? Sharp turns and at vertical tangent lines. Exactly. And so what we need to do is we need to figure out when this derivative is going to break. And so I can't divide by 0 basically. So when will I not exist? When does f prime not exist?
Denominator has to equal 0.
Okay, when my denominator is equal to 0. So when does that happen? At x equals 1 and at x equals what? Negative 1. All right. And so now I have my x values, but what do I actually need? I need a point. So how do I find a point? We substitute it in the original. So we need to find f of 1 and f of negative 1. So when we substitute in 1, we square it, we subtract 1, what do we get? We get 0. And so now we get 0. And when we substitute in negative 1, we also get 0. And so our ordered pairs would be 1, 0 and negative 1, 0. What this graph actually does is it looks kind of like a Whataburger symbol. And so it actually has these sharp turns at -1 and 1, and it has a horizontal tangency at 0, 1. All right. All right. So we have g of t is equal to -7 over the quantity 2t minus 3 squared. Well, this is a rational function. It has a fraction involved. So what rule should we use? Quotient rule. All right. And so I'm going to use the quotient rule first, and then I'm going to show you a trick to never use quotient rule on these again because I don't want to. All right, cool. All right, so let's do a quotient rule. So we have g prime of t. How do I take a derivative using the quotient rule? Because sometimes we have to. This one you don't have to, but we're going to do it anyway. Derivative of the what? Top. What's the derivative of -7? 0. Cool. And then technically it's times the bottom, but it's going to go to 0. All right, and then minus. And now the derivative of what? The bottom. So what comes out front? 2. And then I have 2t minus 3 to the power of 1. However, does chain rule happen on that bad boy? Yes. What pops out? A 2. A 2 pops out. And then times what? -7, the top. So then it's over what? 2t minus 3 squared. So what would that be? To the 4th. All right. And so now we need to simplify it up. So that first part goes to 0, so that goes bye-bye. And so now we have to multiply. So we got -2 times -7, which is how much? Positive 28. And then 2t minus 3. And then I still have it over 2t minus 3 to the power of 4. However, we can still simplify this because why? The 2t's minus 3 can cancel. So this goes bye-bye, and this one will reduce to a cube. All right. And so now I'm left with 28 over 2t minus 3 cubed. So could we take a derivative using the quotient rule? Yes. However, I want you to notice that there's a monomial, and it does not have a variable with it. So for me, I would actually like change the way g of t looks. All right. And so this could actually be rewritten as -7 and then times the quantity 2t minus 3 to the power of what? What if I brought them upstairs? It'd be -2. And so now after we rewrote it, it can go really quick. All right. And so again, let's take a derivative. So g prime of t equals what now? Now what gets to go down to play? The -2 plays with -7 to become what? Positive 14. And then I have 2t minus 3, now to the power of what? -3. And then we have to remember the chain rule. So what pops out? A 2. And so now let's simplify this up. So then 14 times 2 is how much? 28. And then this goes to the basement. So now we have 2t minus 3 cubed. And so, well, looky there. Are they the samesies? Which one was easier? The second one. All right. All right, so this first one, we have y equals 3x secant of x squared. On this first one, I got y equals 3x secant of x squared. And so what's actually happening with 3x and secant of x squared? They're being multiplied. So what rule do I still need to use? The product rule. All right. And so this 3x is my first, and this secant of x squared is my second. All right. So how do I notate taking a derivative? dy dx. And so now let's use product rule. So what's the derivative of my first? 3. And then I still have what? Secant of x squared. And then plus, now I have to take the derivative of secant of x squared. And this is actually a composite. So what's my outer? Secant. What's my inner? X squared. So the first thing I need to do is take the derivative of secant. So what's the derivative of secant? Secant x tan x. So now I have secant of x squared, tangent of x squared. Now I still haven't completed my derivative of my second. What pops out by the chain rule? A 2x. So that's my derivative of my second. So I need to now times it by my first. So what's my first? 3x. All right. And so there's my calculus. Now I have to do a little bit of algebra. So let's clean this up a little bit. And so I still have 3 secant of x squared. And then plus, now what does this 2x and 3x combine to? 6x squared. And I have secant of x squared, tangent of x squared. And so now what can we factor out? Okay, give me more. 3 secant x squared. Love it. And so now I can factor out a 3 secant x squared. And so now what's left? 1 and then plus 2x squared. And then times tangent of x squared. All right, so this one is our peanut M&M. So, what is my outermost composite?
3 tangent x cubed.
Cubed. Cubed is my outermost composite. Then what's my chocolate? What's my inside of that? It's just tangent. Tangent's my next. Then what?
2x.
Then 2x. So my outermost is cubed. Then I have tangent. Then I have 2x.
So the 3 is just the constant tangent.
Sure. So this is the same thing as saying 3 times tangent of 2x quantity cubed. Now let's take, so this is actually 2 chains. All right. All right, here we go. So how do we take a derivative of this? We notate it by what? H prime of x. So what gets to come out first? The cubed. So now the cubed plays with the 3 to become what? 9. And now I have tangent of 2x quantity what? Squared. Now I need to take the derivative of what? Tangent. So what is the derivative of tangent? Secant squared of 2x. Now I have to take the derivative of what? 2x. So what's the derivative of 2x? 2. And so that was actually 2 chains. And now we just have to simplify it up just a little bit. And so 2 times 9 is 18. So now I have 18, and then I have tangent squared of 2x, and I have secant squared of 2x. And there is my derivative. All right. Ready?
Explain that.
All right, Miss Walker, what's after 18?
6, 7.
All right, thank you.